Alright, these are the notes on section 4 of chapter 3. This is on geometric progressions. So geometric series is defined where we have a1 equals a and a sub n plus 1 equals a sub n times r, which is going to be a common ratio. And that's going to stay constant for the entire series. So in 2, 4, 8, 16, so on. You see a1 is 2, a2 is 4, a3 is 8, so on. And if you want to figure out what the common ratio is, we could say take a sub 2 times r will equal a sub 2 plus 1 or 3. So you have a equals 4 times r, or r equals 2. What you might have noticed, based on the way I did this, is that a3 over a2 also equals r. And this is true for this. This can be heavily generalized to the statement that a to the n plus some a over a to the n equals r to the a. So if you have a sub 7 over a sub 3, since this is 4 larger, that's going to be equal to r to the 4th. So, you defining give an example of a geometric series. It can also be something like this, where the common ratio is negative 10 over 5, where that equals r, and then this will equal negative 2. And a trap that you want to avoid, because we know that this is negative 2, but let's just say you took the outermost ones, 20 over 5 equals r squared. You got 4 equals r squared, so plus or minus 2 equals r. You have to consider which one of these two is actually correct. You can go through and see it's negative 2. So, as a, I don't know. Okay, well, we had just a1, a2, a3. Remember, if we have a3 over a1 equals r squared, we can rearrange what we have and a sub 8, I can't words today. So we have a sub 3 over a1 equals some r squared. And we also have a sub 2 over a sub 1 equals r. So, I don't even know why I did this. This should be a sub 3 over a sub 2 equals r, and a sub 2 over a sub 1 equals r. So that means a sub 3 over a sub 2 equals a sub 2 over a sub 1. Therefore, a sub 2 squared equals a sub 3 times a sub 1, which means we can say a sub 2 equals the square root of a sub 3 times a sub 1, which is this is the geometric mean. That's what this is. Because it's kind of like the arithmetic mean, which is a1 plus a3 all over 2. This is a3 times a1 taking the square root, and then we get a sub 2. Alright, so, let's say we want to find some nth term. We've already kind of established how this works. We have a sub n is going to equal a, first off, times some r, but we know how many times we have r is n minus 1. You can check this, a sub 1 will just equal a times 1, which makes sense because that's the way to find a, is a equals a sub 1. So, given we have this list of 4 variables, and given 3 of them, we can determine the 4th one. So let's say we're trying to figure out what the common ratio is. You take, and we have a sub n equals 64, a equals 4, and we've done this, and we'll say n equals 3. So this is our third term in our geometric series, starting with 4, ending with 64. What's the common ratio? Well, we can plug this in. We get 64 equals 4 times some r to the n minus 1, or 16 equals, or not n minus, I can rewrite that as 3 minus 1, so 16 equals r squared, so 4 equal, or plus or minus 4 equals r. And if you think about it, if we have 4, we'll try one series where we have the positive 4 and one series with the negative 4. So we'll have 4, 16, 64, where we go with positive. If we go with negative, we'll have 4, negative 16, but then back to regular 64. So either of these could be the common ratio, since we do not have enough information to determine which one of those two it is. And last step show how to find the sum of a geometric series. So we'll start this off very similar to how we find the sum of an arithmetic series. A1 plus A1 times R plus A1 times R squared, all the way to A1 plus R to the n minus 1. Then we're going to find this other series, R times S equals A1 times R plus A1 times R squared plus A1 times R cubed, all the way up to A1, this should be times R to the n. Because you see, since we're multiplying this by R, we just multiply each of these by R, since it's addition. And then we can subtract these two series. We get S minus R times S. And that will equal, what does it equal? So it equals A1 minus this quantity A1 times R to the n. You're like, why does this happen? Well, if we subtract, these two cancel, and then all the way up, well, this will cancel, and then this will cancel the last term before this happens. And we're just left by subtracting this from that. We got that right here. So then we can say S, factor of the S is times 1 minus R equals A1 minus A1 times R to the n. And then we can finally write this as S equals A1 minus A1 times R to the n, all over 1 minus R, or easier to remember, first minus last plus 1 term, or I guess better, 1 after last, all over 1 minus R, which I think is easy to remember. So if we use this formula, alright, so I did cut the video there, be right back here. So we'll practice this with a sum from SK equals, let's say 0 to 4 of 19 times 1 point, actually I'll just go easy, 2 to the K. So the first term is just going to be, when we plug this in there, we get 19 minus what's the term after. Well, we put a 5 in for this. It's going to be 32. 32 times 19, 8, 1, 28, 0, 2, 3, 8, 608 over 1 minus 2, because that's our common ratio. So then we're going to get negative 589 over negative 1, so that should equal 589. And that should be it for